with a theoretical part of things, let's say. We're going to be having this workshop essentially split into two parts, a theoretical one and a practical one. Yeah, generally going to be starting, generally going to be answering like, what is the indexing and what SubQuery is trying to do. So indexing is a process of obtaining data from blockchain, I mean data indexing, blockchain data indexing in our case. It's a process of obtaining data from blockchain and to handle it somehow and to query it. So, and to enable the querying of it. Sorry for this. So, why would you even need it? So think of the any popular decentralized application out there. Think of any wallet, for instance. So every wallet is having a use case of essentially showing the transactions of the user of the address that essentially was completed the transaction from the application. And in order for the application to fetch some such kind of data, it's having like several tracks. One of the tracks is just directly go to RPC and trying to obtain data from there, somehow try to find the relevant transfer or like any transaction completed by a certain user from all the blocks, from all the transactions, handle it, save it, and display it. As you can imagine, that's going to be quite a complicated task to be completed by app. Needless to say, it's going to be quite hard for the mobile devices, for instance, with lower computational power to do it. So instead, something what's called an indexer could be leveraged in this. So indexer is essentially a software which is trying to connect to RPC, trying to fetch the raw data of blockchain. So if it's a EVM blockchain, it's going to be it's going to be fetching the primitives like events, transactions, and blocks. Once this primitive is fetched, it's then going to be handled somehow, saved, and served via an API. So SubQuery is essentially doing all of this. So the API isn't limited to any kind of a specification. So the developers are totally flexible to have their own API schema. And I'm going to be demoing it a little bit later. Yeah, generally, SubQuery is end-to-end indexing solution. So what's implied by this? One of the most important products of SubQuery is a developer SDK, TypeScript SubQuery SDK, essentially allowing anyone to run one's indexer. And let's say you've developed already your application, you've validated it, I don't know, locally somehow, for instance. So, and now you'll probably be interested in deploying it somewhere so that the decentralized applications are obtaining data from it. So you're going to be having like several options in this case. You could probably just self-host. You can use the managed services, which is a centralized cloud developed by SubQuery team for mostly SubQuery projects, as well as subgraphs. And there is also a decentralized marketplace, SubQuery network, a completely decentralized solution. Essentially, yes, SubQuery provides all those services and allowing the complete integration and development of indexing infrastructure. Our focus today is going to be only on the SDK part, and I'm also going to be previewing a little bit of managed services as well. So SubQuery having its own unique set of features and things why it's different. So it's completely open source. The SDK could be found in GitHub. One could not only contribute to the code, but also shape the requirements engineering, find bugs, propose improvements, etc. Secondly, it's very easy to speed up. You're seeing the Docker icon here, so it's completely Docker friendly, so local setup friendly and self-host setup friendly as well. It's quite simple to configure. Only 3 types of files need to be created and set. It's very customizable because at the end of the day, every SubQuery project is a TypeScript project. It's very fast. SubQuery team been doing the benchmarks and they're really good. It's feature rich. Some of the unique features of SubQuery are, I don't know, type safety or cache architecture, multi-chain, WebSockets, and like much more. Everything could be found in documentation. So about real-time, actually coming back to WebSockets. So instead of polling your indexer, you would be able to subscribe to the changes via WebSocket and receive all the updates real-time. It's multi-chain, so from a single SubQuery indexer, you're able to connect to multiple network of heterogeneous nature and index data from there. So let's say you're trying to build you've built a cross-chain protocol and are interested in developing a dApp for it. So you'll probably be interested in the execution of the transactions cross-chain. So you need to connect to both chains and see execution on both sides of things, on the source and the target. And yeah, with SubQuery you can use a single project that will consolidate all the data within a database. Really flexible. Not only you can work with deterministic data, such as the one that could be found in such as the blockchain essentially, but you can also create off-chain data like coin market cap prices or like anything else. And it's compatible with many networks of several architectures, including EVM networks, Cosmos, Substrate, Algorand, Stella, and so on. So yeah, this is a visual schema that essentially recaps what I was previously explaining, why indexes are needed. So we're seeing a SubQuery SDK standing here in between the blockchain and essentially raw data that could be found there. Database, which is populated by SubQuery indexer with only subset of really needed data, not like everything that could be found in blockchains. And then the data from the database served via GraphQL to different apps, including block explorers, dApps, mobile analytics, and so on and so forth. To run SubQuery locally, there are some prerequisites, one of which are having the Node.js installed locally. Also Docker, because it's the simplest way to start all the necessary components, and the SubQuery CLI to build, to generate code, and so on. And there are 3 simple steps, as I was previously talking about, that are required for the configuration of any SubQuery indexer. And those are the configuration of schema, manifest, and mappings files. I'm going to be demoing it very soon. So the SubQuery team also prepared a small template to follow and to streamline the onboarding to indexing, the SubQuery indexer developing on Zeta Chain. And I'm going to be demoing you a project that could be found by this link. And the goal would be to index all transfer events and messages of wrapped Ethereum on Zeta Chain mainnet EVM. So yeah, I'm gonna be switching to demo. Maybe, are we having any questions already that we could probably answer?
Yeah, I don't think we have any questions in chat, but yeah, I'm excited to see the demo. I might have some questions after the demo myself.
Sounds good. So this is a ERC20 token token address of Route Ethereum provided by Zeta Chain team, and as you can see, it's having like a bunch of really familiar logs like approval, transfer, and this is because this contract is implementing the interfaces of ZRC20 or ERC20, so it's really easy to work with. This is how it looks like in Ethereum Explorer, and yeah, we can proceed to the configuration itself. So I'm going to be sharing the example project from this repo. It could be found here in the Zeta Chain folder. And if you open it, you'll be able to see two subfolders: Zeta Chain, a starter for Zeta Chain, and a starter from Zeta Chain testnet. We're going to be going over the Zeta Chain starter mainnet project here. So let me actually close all the tabs here. Let me know if I should zoom in a little bit.
Yeah, I think zooming in a bit
yeah.
would help our viewers.
Would it help? Should be
Yeah, that's
easy
great.
enough? Good. So yeah, Zeta Chain Starter is a starter project, and it's already having 3 necessary files configured here. So the first type of file is a schema file, which is allowing to specify the specifications, the interfaces of the API that's going to be serving the index data. So here we're having a complete flexibility, and yeah, we're having created 2 entities. Transfer and approval, each entity is having its own set of properties. So for transfer, there is ID, block height 2, from value contract address, and for approval, there are different properties. So if you're familiar with databases, you can just think of those as yeah, tables in a database, which could also have the relationships. So yeah, in this file, we're manifesting the API. Second type of file is a manifest file, which is usually configured under project.ts. Here we're having a complete configuration for Zeta Chain. So this is a project name. We're indicating the EVM chain ID, which is 7000. We're also indicating the endpoints that we want to be connecting to fetch those data primitives. And finally, we are indicating those data primitives that we want to be working with. So first of all, we're telling the indexer that if the source of data that we're planning to work with is EVM. We're also indicating this start block. We are helping it with type generation by providing the ABI and specific smart contract address, which matches with the one that we've previously seen in the Block Explorer. So ends with 891, and we're having the same address here. And finally, we start setting up something what's called handlers. I'm going to be explaining, we're having two handlers here. I'm going to be explaining them one by one. So the first handler is a EVM event handler. Essentially, we're telling the indexer, please connect to an RPC node, start the indexing of blocks one by one, and if you see the event with that specific topic, please pass it to a function called handle lock, which is going to be configured up as part of the configuration of the third types of files, which are mapping files. So essentially, what Indexer is doing here is just looking to the blockchain. It finds the primitive that one is asked to find and just passes it then to a function, a handler, which is called handle log in our case. This is for events. For transactions, there is a different there's a different kind where we're asking to index a call with a specific function, so approve in our case. So a very simple example to do. Yeah, and then it's this approve call is going to be passed to handle transaction. Those two handlers are configured as part of a third types of files, which are mappings files. So we can see the same functions here, handle log and handle transaction. As you can see, it's the handle log function is accepting the log, which is of a transfer log type, which is automatically generated from the ABI file that was provided. Once it's being, so when it's being handled, it's first of all prints the block number of the event. It's also checks, it's also doing some assertions for safety of the indexing. And it's finally creating it's populating the transfer entity that was previously created as part of a schema file, so this transfer. It populates it with its properties with the data from the event itself. So for instance, for ID, it's taking the transaction hash. Since we're having the type safety here, we can just like access the objects and do it for all the necessary properties that we're having here. So for block height, we are accessing the block number, converting it to big int, and similar things we do with other properties. And finally, we just save to a database and make the specific specific transfer queryable. So just to recap, we only need to configure 3 types of files: a schema file, a manifest file, and a mapping file, which is essentially connecting manifests files to the schema itself, just by handling the primitives somehow and saving them to a database in the specific in the specification that we've previously manifested. Yeah, same goes for handle transaction and mappings files. There are yeah, and this is actually it. So we can run the project. It's completely local environment friendly, so it could be run with Docker Compose. Only 3 services need to be run, which are Postgres database, the GraphQL engine and API, and finally an indexer itself. So Postgres for storing data, SubQuery node for fetching data from blockchain and saving it to database, GraphQL engine to serve data from database. It's really easy to run it locally. So you just need to type npm run dev, and here we're having the script. So first the necessary code generation will be completed, then the project will build, and finally all three components will be deployed from Docker Compose. Yeah, and I've already started the indexing in managed services, so I'm not going to be running it in Docker Compose, just for just to save some time. So it's what you can see now is a UI from the SubQuery managed services, a centralized cloud, but like it's very similar to the one that you would see if you would run it locally. So, for instance, yeah, this is a localhost 3000, and as you can see, both GraphQL interface here and in the managed services, they like look very similar. So since the indexing was running for some time already, we can query data. So let us actually query transfers. First 5 index transfers, and as you can see, we have data being fetched. So if we take any transaction and just copy paste it to a block explorer, then you're going to be seeing the index data just like you're able to see it from a block explorer. Obviously, with indexes, you're not limited to those primitives that you can only see in the block explorer itself. You can you can be more flexible in trying to fetch the data that you need. So, for instance, we can do the aggregations. We can I don't know, calculate the sum of all the transfers completed for this specific smart contract that we're indexing. So if I run this command now, it's going to be performing the aggregations automatically for me, which might be very convenient for the apps, just because the apps won't need to perform the aggregations themselves, because it's quite a heavy task to be completed, especially on the devices that are low in resources. So SubQuery is helping with that. So yeah, what I also wanted to show you is probably more topical for ZettaChain. So what I've just showed you was just a template example, which is very simple and very easy to configure. It's only relates to ZettaChain EVM. But given the vision of ZettaChain and essentially it's providing the cross-chain services, it might make sense to, explore the possibility of multi-chain and to index multi-chain ZettaChain data. For that, you can index, you can leverage something what is called a multi-chain indexing, multi-chain support. This is a page from official SubQuery documentation, which is explaining the exact configuration of such a process. But you can also find the example of multi-chain indexing in the official example repository. So for instance, here's a multi-chain example project for Seller Bridge, which is just a completely random project, but which is having the smart contracts deployed across multiple networks, including those that you can see here. So same could be done for Zeta-chain smart contracts deployed across multiple networks. And yeah, this is pretty easy to configure. And again, you can leverage both multi-chain and, for instance, aggregations within a single project. Multi-chain for centralized data access and data being stored in a centralized manner, and aggregations for for the economy of the computational resources of the client applications, for instance. Yeah, so what I also wanted to mention is a decentralized data network. So SubQuery is offering the services of decentralized data access, because as somebody who's developing a decentralized application, you'll probably be interested in using the decentralized infrastructure, which SubQuery network is providing. So this is a link to documentation, and I've been showing you the multi-chain article from it, but you can find all the intricacies of configuration there. And this is a link to SubQuery Discord community, the best place to ask the technical questions, and any other questions as well. Yeah, I think we're good in terms of demo. So happy to answer any questions if there are any, and maybe help with configuration live.